Lesson 3, Modeling Data Using Exponential Functions. So this is very similar to last unit. You're going to graph the points from a table of values and then graph the regression line. But instead of putting linear, quadratic, or cubic, we're doing exponential. So the population of Canada from 1871 to 1971 is shown in the table below. Determine an algebraic model for the data. So for our x's, we're going to go in groups of 10. So this is 0 groups of 10 because it's starting at 1871. And then it's 1, 2, 3, 4, 5, 2, 3, 4, 5, 6, 7, 8, 9, and 10. It should be 10. One second. So when we're graphing this, instead of putting 1871 for x, we're just going to put 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So to graph the calculator, first make sure your calculator is erased. If it's not erased, push second function, memory, delete all, and then delete everything. So the first thing we're going to push is stat, and then we're going to push edit, so you push 1, and you'll come up with the list screen. Then you're going to enter your data using the numbers and the enter key. When it's done entering the data, it should look something like this. So pause the video and see if you get the same data as me. So your list should be entered like this. So 0, 1, 2, 3, 4, 5, 6, blah, 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 all the way to 10. Now what you're going to do is you're going to graph to see what kind of function this is. So now we go zoom and then 9 and push enter, or maybe not have to push enter. And your graph should look like this. So you can see that it goes up. This is called exponential growth. So exponential growth is when your y values increase as you move from left to right. It's decay if it's a decreasing function. So now we're going to calculate the regression line from this. So you're going to hit stat, then you want to go to calculate, so you hit right. Then what you're going to do is you're going to push down until you get the exponential regression line at the bottom of the screen, and it should look like this. So way at the bottom is exponential regression. So what you can do is you can hit down, down, down until you get to A and push enter, or you can push alpha and then A, which is math, and that will also get you the exponential regression. Then you push enter and it'll calculate your exponential regression, which should look like this. So this calculates your values for A, B, C, and D. So our exponential model will be y equals 2.66 ... times, so that's for this number. So you should just write down that whole number. A equals 2.6685473729. And B equals 1.239888842. So 1.23 ... And all of this is to the power of x. So that is your function. Now if you were to graph your regression line in, the first thing you'll hit is yx. So you go to yx 1, then you're going to hit vars, and then you're going to hit 5, and then you're going to hit EQ. And remember, you want to get your A value. This is to get your A value. And the way that we write our equation in is y equals A times B to the power of x. So using vars, you should type this into your calculator, and your function should look like this. So that's using vars to get your A and your B. And then when you hit graph, it'll graph your regression line in and it'll look like this. So there's the regression line for your data. So part B says, assuming that the growth continued at the same rate to 2011, estimate the population. So we left off at 1971 was 10 years. So 1981 would be 11, 1991 would be 12, 2001 would be 13, so 2011 would be 14. So we're going to plug in x equals 14 into our equation. So we have y is equal to 2.66 ... times 1.23 ... to the power of 14. Pause the video, type that into your calculator. You should get 54.15 million people would be the population in 2011 based on this function. Okay, example 2. Emma did an experiment to determine the cooling curve of water. She placed the same volume of hot water in a cup and then recorded the temperature of water in each cup as it cooled over time. The following data is determine an algebraic exponential model for the data. Okay, so we're going to enter the data. So first, since the last question, you need to delete your memory. So you're going to push second function, plus sign for delete. You want to delete all, so you'll hit 2. And then you want to push 1. And then you're going to push enter till everything is cleared. So that will clear your calculator out. Now we're going to put it into your list. So you hit stat and then edit. And you'll get to your L1 and your L2, and you're going to put all of your data in, pushing enter between them for your X's and your Y's. So pause the video and put all your data in. Okay, so we have L1, L2, and it should look like this. We've only got 6 pieces of data. So now we're going to graph it to see what it looks like. So you're going to hit zoom and then 9, and it will look like this. So since it is a decreasing function, this is an example of exponential decay. So we want to graph the regression line for the exponential regression. So you're going to hit stat. And then you're going to calculate, so hit 2, or right. Then you want to go all the way down, and it should be 0 on this calculator. So 3 should get, or 0, or your third step would be to hit 0, and you should get your ln reg, which looks like this. And by 0, I totally am getting ahead of myself and thinking of logarithms. We want to hit stat, calculate, and then you can hit alpha A, or you can go all the way down till it says regexp and push enter. So either or works, and you'll get A to be 89.72650942, and you get B to be 0.97258600033. So our equation would be y equals 89.72 ... times 0.977 ... to the power of x. Alright, so using the equation from above, we are going to determine A and B for these following things. So using the data, we're going to find the temperature after 52 minutes, which would mean x equals 52. And we're going to find when the temperature was 51 degrees. So y equals 51. So we're going to plug these into our equations. So we have y equals 89.7265 So then we're going to write our next number, which is 0.972586003, and this is going to be to the power of 52. And if you type that all in, you should get 21.1 degrees. So after 52 minutes, there's 21.1 degrees. Now we're going to do this, and this is a little bit different. It's something you haven't done before. So you have y is 51 equals 89.72650942 times 0.972586003 to the power of x. So when x is an exponent, what you want to do first is isolate your base with the exponent. So we're going to divide by 89.72. So this and this will cancel. And on the left side, you should be left with 0.568393893. And what you do, I'm going to put a little space there. What you do to get rid of the x in the exponent is you're going to take the logarithm of it, the natural logarithm of it. So you're going to take the ln of both sides. So this would be the logarithm of 0.972586003 to the power of x. And as it says above in your notes, when you have log of some number, some base to the power of x, you can write it as x and then the log of a. So we can rewrite this one as x log of 0.97 ... Now to get x by itself, we divide by the logarithm of 0.97 ... And when you type it into your calculator, you should write all the decimals in because it doesn't tell us to round, so we're not going to. So if you take the logarithm of 0.568393,893 and divide it by the logarithm of 0.972566003, you get 20.3 to equal x. So roughly 20.3 minutes, the temperature was 51 degrees.